Hi everyone. Today we are going to learn about some of the applications where language processing we can use. Okay, so the first very good application is your information retrieval. So how far this information retrieval will be helping us to understand where we can use, how we can actually use all the techniques and everything. So for that we are going to understand information retrieval. Information retrieval generally will identify how to represent the data, how the whole data which is having very large amount of um, sentences or large amount of topics or paragraphs are existing. From that, how we can actually identify all this important data from that. So for that, we are going to understand some of the metrics and some of the techniques also in this lecture. So for suppose if you have any data with you, which can be any newspaper article, or if you are having any novel uh, in the place of in the style of your PDF or any paragraphs or anything, how we can actually understand, how we can model the topic. Also, we can learn from this, especially with your information retrieval systems. Information retrieval systems is definitely a very different chapter. It's a very different or unique subject where we can go in and we can dive into more detail actually. So this will organize the information whatever we can retrieve from your data, and also we can create some queries. We can also understand how we can raise questions and how we can answer some questions also, whatever we can retrieve from that. So information retrieval systems, so whatever what and wherever it has been used, so it will use some of the metrics. So among those metrics, we are going to learn some from that today. So first of all, we should understand what we can actually retrieve from your document. So first step is we should make it pre-processing. We know how pre-processing will be starting with, especially we will tokenize them into different tokens. If you consider it as a raw document, we should tokenize that. So from that tokenization, we should also understand what are smallest possible meanings from every unit of the tokens, whatever we have tokenized. From those tokens, we should be able to identify some of the vocabulary items. We will see what are the vocabulary items, how we can identify vocabulary items. So generally, if you check this document, first of all, we should also understand the syntax. So syntax will be understood depends on the file type. So it can be a PDF file, it can be a Word file, or it can be an HTML file also. So from that type of file only, the document can be understood. So especially the syntax should be understandable, because if you take an HTML file, there will be some HTML tag. Generally, a topic will be retrieved from the body tag of your HTML. Okay, but if it is a PDF file, again it might contain images or it might contain text. If it is a PDF file, we will be able to identify, or we will be able to copy the content if the text copying was enabled. If not, we cannot do that. So your tool or the program, whatever you are about to write inside, or if you want to retrieve anything from that, your program should be able to identify the text from that file. That's the reason the file type is very important here. So if your program is able to identify the file type, we should also identify how it might sync with your computer, because the number of bytes and the understanding of your text, especially with your ASCII code, is also important. So we will see some of the your information retrieval, especially with your monolingual information retrieval systems. For suppose if your program or if your syntax, whatever you have written, if it is only apt for one language, so that language specific pre-processing we can do. It will be a very easier task. For suppose if you take English as your language. So and if you have developed your program to understand English specific topics. So monolingual information retrieval system and the pre-processing technique will help us. So in this entire technique, we will be understanding document representation, index structure, retrieval models, and some of the priori models. So we will see what are they in the due course. So first of all, if you read document representation, so the pre-processing of your document generally understand what are the tokens, how the tokens were arranged, how the tokens were represented. So there will be a stream of data. You might also know what is a stream of data. That stream of data will make you to understand how the tokens were arranged syntactically and semantically as well. And these tokens can be understood with the help of their stem words, with their lemma words, and also with their n-grams. We have also know what are n-grams, so where we can actually identify some pairs of words, where those pairs of words will make us to understand the meaning of their existence in your entire topic. And there is also a model which are dependent on vocabulary and also independent of vocabulary. Okay, so likewise we can understand how IR models, information retrieval models, will help us. And the very thing is how many times the individual term has been occurred. So it depends on the individual term occurrences. Also, we can also prioritize whether this term can be used for suppose to summarize your text, or for suppose if you want to summarize any movie topic. If you take any movie topic and if you want to collect all the subtitles of a movie, that is the movie entire discussion of your movie, where that movie context can be understood from the entire subscenes or subtitles. So likewise, to know that there will be some terms specifically where it might be occurring at many point of time, at many timelines of a movie. So likewise, we can also identify the number of terms occurrences as well, and those may be dependent on the vocabulary and also independent of the vocabulary. So this dependencies should be represented using a vector space model. So we should also provide them as vectors. So all those vectors will help us to understand how many times and how much good the occurrences of a specific token or a term will be occurred. And in this representation of vectors, we will be using a function, let it be f, and which might map all the documents to the vector d. Okay, there are some different functions where how we can use all these documents, especially with the vector representation. So there are two models that we can understand, especially in your vector representation. One is your Boolean document model. So this Boolean document model will make us to understand how good the values, uh, good the values we can arrange, especially in the terms of zeros and ones, because we know Boolean model is containing zeros and ones. So this model is nothing but called as your bag of words model. Okay, the other thing is your term frequency document model. So term frequency document model. So whenever we have given all these dimensions like your vectors, especially with your Boolean document model, we will be identify how many times an individual term has been identified, or a individual term has been occurred in your entire document. So that is how term frequency will be calculated. So we'll see the first model, which is bag of words model. So bag of words model is a very simple algorithm, especially in your NLP. So this uh, bag of word model actually will take all the bag which containing some words. So all these words, whatever we might understood, we might identify in your entire document, will be vectorized in your Boolean format. Okay, so that we will see with an example as well. So if you take any simple example like this, with a small topic like I love this movie, it's sweet but with the satirical humor, the dialogue is great and the adventure scenes are functioning. So all these are all this entire words of set of the topic, whatever it was there. So especially there are some important words like movie, sweet, fun, humor, satirical, romantic, conventions, fairy tale, and happy. So these are, and have a friend. So these are some of the words which are very important. So first of all, we should be identifying all those individual occurrences of this topic, and we should have how many times these were occurred also. So we'll see with a detailed example. For suppose if you take, these are four different documents. If we have, it was the best of times, it was the worst of times, it was the age of wisdom, it was the age of foolishness as well. So if we take all these four as different documents, okay, so let's consider everything are different documents which are in my corpus of data. So now we should identify the vocabulary. How a vocabulary can be identified? So if you take it was the, so these are the three words and also of. So these are the 4 words which are repeated from all the documents of all the Word documents. So irrespective of that, we have best, times also repeated twice, and age also repeated twice. So 1, 2, 3, 4, 5, 6. These are the minimum. 7, 8, 9, 10. So now my vocabulary size will be 10. So these are all the words where actually if you consider all the 24 words of your entire 4 documents, we have only 10 words which are unique, and those 10 words will be considered as vocabulary. Okay. In considering this vocabulary, we are ignoring the cases, and also we can also ignore the punctuations. The very important thing is you should identify, or you should decide whether to consider stop words or not. Okay, considering the stop words will give you another result. Without considering stop words will give you other result. So the in the process of consideration of your stop words and removing all the punctuations um, will give somewhat better results whenever we don't consider the stop words. So likewise, there are so many different scenarios, depends on your topics, depends on your model, and depends on your requirement. You should change your design of your entire logic. Now, let's consider the document vectors. As we have considered the 4 different documents, we have divided that into, and we have identified the vocabulary of words where we can generally create the vector of data. Now, let's create vector of the document vectors. So, first thing is we should score every word in your each document, and again we should identify, especially with respective to the vocabulary, whatever vocabulary we have, according to those vocabulary we are going to represent, and we are going to mark them with your Boolean word model, especially Boolean document model, like your bag of words model with the representation of 0 or 1. If a word was present in your vocabulary, we are making the value as 1, and if it was not present, we are marking it as 0. Okay, so let's check with your example. So let's check this one. So for suppose if we are having the first one, it was the best of times. If you consider the first one, all the it was, as it was especially it was existing with your vocabulary, we are marking it as 1. Was with 1, the with 1, the with 1, best with 1, off with 1, and times with 1. As worst, age, wisdom, foolishness are not part of your first document, we are marking them as zeros. So the vector of values can be represented in this format. So like this. So now if you consider the next 3 documents as well, so this is how we can actually present. So these are all the vector of data where we can represent with your Boolean document model. So document 1, so as we know, it was the first document we have, it was the best of times. The first one, it was the best of times, so it was there, so we are marking it as 1. Was there, we are marking it as 1. The is there, best is there, worst is there, times is there. So all the values were marked as 1. We don't have worst, so it was the best times. So off was not there, off we have off was not there here. So sometimes off will be identified like one of the preposition, and it might not be also considered. So it depends. Again, we should check properly whether every word was given or not. If not, we should tabulate them. Okay, so likewise we should be able to identify those vector of data. So all these vectors, whatever we presented, we should label them with zeros and ones. Till here, this is only bag of words model. Okay, so we are going to identify the vocabulary. We are considering every document. We should, from those identified vocabulary items, we should be trying to map every document, how and where and it was existed. So every existing token from every document will be marked with a vector value as 1. This is still how, till this we can identify the bag of words model. Next is your term frequency. So the document representation, by identifying your term frequency, we can create a very good result. So what is that model is term frequency product with inverse document frequency document model. That is what in shortcut we call it as TF.IDF model. Okay, so especially we will be identifying term frequency, and also we have a responsibility to product with inverse document frequency value as well. Now, if you take the document frequency of term, so how many times a particular word has been appeared, so that frequency we will be storing, and also we will be identifying some inverse document frequency. So this will actually create or add some weight to identify some of the infrequent terms, and also which have less weight on the frequent terms, so that it will discriminate every document in your entire corpus of data. Especially we will be using logarithmic on your term frequencies. So term frequency, first we will be calculating the term frequency. The term frequency will be the number of times a word occur in your entire document divided by the total number of words in your document. And the second part is your inverse document frequency. So we'll see how they will working. First we'll identify what is term frequency. So term frequency will be having number of instances of word W in document D divided by total number of words in document D. So if you take number of instances of a word W, if you check the previous example, it has been appeared 4 times from your entire vocabulary. So that means the numerator will be number of instances of word W in document D. So if you consider one document D, or the entire times number of times your word document D has been occurred, that will be the numerator, and the total, and the denominator will be total number of words in your document D. Now how inverse document frequency will be working? So it will be logarithmic of total number of documents N in text corpus D divided by number of documents containing W. So total number of documents N in text corpus D. So how many documents we have, okay, in your entire corpus G, and divided by number of documents contained in W. For suppose if you check it here, how many documents it contains? 4. And how many documents you have? 4. So it will be log of 4 divided by 4. If you want to identify inverse term, inverse document frequency of it word, it will be log of 4 by 4. That will be 1, and it will be 0. So that means it has been appeared more frequently. Okay, so it was 0, and it might not be important in some other context as well, because it is representing some of the any thing or any other element or any other object as well. The object can be an actor, the object can be any situation, an object can be any product or anything that we want to address in your entire topic. So after all identifying your inverse document frequency, we will be product with your term frequency. The product of both term frequency and IDF, that means inverse document frequency, we will be identifying. Let's consider an example like this. Let's consider 3 documents. It is going to rain today. Today I am not going outside. I am going to watch the season premiere. So generally the first step is we should identify the vocabulary of data. So we have considered some of the vocabulary items, so not all the vocabulary items. So some of the vocabulary items. So if you consider going has been appeared thrice, to has been appeared twice, today twice, I twice, am twice, it is, rain, season, premiere, outside. There are some words which might appear only once. So this is how we are going to identify, and these are the term frequency item, term frequency values. So what are the term frequency values? We have number of instances of a word W in document D divided by total number of words in document D. So it will be 0.16 for going, to will be 0.16, today will be 0.16, I will be 0, okay, am will be 0. So this is how, these are all the term frequency values. After identifying the term frequency values, okay, for now for one document it will be, for the second document these are the values, and for the third document these are the values. So if you consider going for the first document it will be 0.16, second document 0.16, and also the third document it will be 0.12, especially for your going. So these are all the term frequencies if you consider for all these 3 documents. Now whenever we want to calculate the inverse document frequencies, for going it is logarithmic value of 3 divided by 3, 2 is logarithmic value of 3 divided by 2. So as per the formula of inverse document frequency, total number of documents N in text corpus D. For suppose if you take the first one, going. So going will be all the 3 times it is appeared, that's the reason 3 divided by 3. Next coming to 2. So 2 has been appeared only in 2 documents. That's the reason denominator has been 2. And how many documents we have? 3. That's the reason it is 3 by 2. So if you check, all the numerators are 3. That means how many total number of documents we are about to consider, that will be your numerator, and how many documents a particular word has been appeared, that will be your denominator. Okay, that will be your inverse document frequency value. Now, if we have uh, inverse document frequency value of going, this will be inverse document frequency value will be for your entire corpus of documents, but the term frequencies whatever we have identified, those are particular with a particular document. So please understand how term frequency is providing us the values and how inverse document frequency is providing the values. Term frequency values are particular with your document, but inverse document frequencies are total the values which were generated with respective to the entire corpus of data. That means as we have 3 documents, this will be entire corpus of data, and inverse document frequency will be concentrating on the entire corpus of data. Now our time is to product your both the values. So whenever I product going with your uh, idea where the product of term frequency of going with respect to document and your IDF1, so these are all the values whatever we will get if after all we have producted them. Okay, so this is how whenever we get, so document 1, so going we got 0, because why going we got 0, because already we have IDF value as 0 here. So so for going all the 3 documents, even though if we product it will be 0. And 2, so we will be producting the value out to 0.41, which is produced with 0.16, 0 and 0.12. So that's the reason we got all the values. So these are all the values of TF.IDF. So from these values, we can come to a conclusion that it is rain. So these are the 3 terms which got some of the higher values here. So these higher values might help us to summarize your text, might help us to model your text, how good we can use all these 3 words as well later. So this is till here we have extracted some of the features, and we have identified which value have uh, how much value we can actually identify with your TF.IDF. It will be looking like some of the probability value as well, but we have not used any probabilities here, but we can also consider some values which might range from 0 to 1. So now this is a very important stage as we have got your TF.IDF. Let's take another example. So in identifying your TF and IDF, let's take 2 documents. It is a sunny day in Karlsruhe, and it rains and rains and rains the whole day. If we consider these 2 documents, this is how we can actually identify your entire TF.IDF. So this is how sunny was identified. So these are the 4, let's consider these are the 4 vocabulary individual words. So here we have removed all it is here, that means all the stop words were removed. So we have only considered very important nouns, especially okay, sunny day, Karlsruhe and rain. So from these 4 things we can identify the values, and we will also get some values. And there is also occurrence of more than one where, that means rains have a more the highest value when you compare with your entire document. So this also, and this value might help us to identify these values will help us to identify rains as one of the very important part of your entire document. So how we can index them? So the entire words, whatever we got, so these are the values. Now we can also index these words. So if you check sunny, whatever sunny we have, so document 1 it appeared once. Day has been appeared document 1 and document 2, and document 1 it has been appeared once, and document 2 it has been appeared twice. Like with Karlsruhe it has been appeared in document 1 one time, and rains has been appeared in document 2 thrice. So this is how we can also index it. So this indexing is very much important, so that where in which document it has been appeared, after identifying all these TF-IDF values, it is also important in which document it has been appeared as with respect to the term frequency, because whenever we want to model any topic, we can also identify, it is our duty to majorly consider which document in your entire corpus to summarize your text. Okay, and it is also very much important to have inverted index as well. So where this inverted index also will provide us how many times we are dereferencing a particular term as well. Okay, so this is how you can use your index structures. So there are different retrieval models, as we have discussed: Boolean models, vector space models, and also probabilistic models. We have seen these two, especially in your Boolean model and your vector space models, with your bag of words model and your term frequency and IDF model. So we will just check in detail how these Boolean models, so Boolean retrieval model, especially it has been matching with your binary vectors, whatever we have given, and also the current vector space or your probabilistic models might outperform your Boolean models as well. So Boolean vector space model, it is a representation wherever we have used, especially by identifying your matrix of data, by identifying your term frequency and your IDFs. And there are some different models as well, which is accumulative model. Generally, it will compute the scores of each and every query term. So whatever query we require, query we got, so according to that query, we are going to identify some scores. And there are some functions which will be computing all these scores so that it will be getting your single query term like all these measures. So if you take the first one, a term frequency in the document, so that's what we have seen, and also we'll be identifying the length of the document, and we'll be identifying the document frequency of the query term, and also number of tokens of query term in the whole collection will be identified. And these are all the metrics that we are going to consider. From that, we can also calculate the score with the summation of your term frequencies and logarithmic of your length of number of documents in your entire collection divided by your document frequency of query term. So this is how we can also identify the score of every term. So whatever query we get, so we can also identify this score. So there are also geometric models where we'll be using cosine similarity. So cosine similarity, especially it will be applied in your retrieval models. So this will actually take the vector space of data, whatever query we got, how many how much well we have mapped your vector of data, whatever query we received. Okay, so that is how we can calculate the score of the query with respect to the list of documents. Those are the two arguments, and we will be identifying your cosine of those values. When coming to your probabilistic models, so probabilistic models also, it is identifying your likelihood, so identifying your maximum likelihood values from your documents. And we can also provide a very well information, especially with your query expansion, where this query expansion will provide you how to add, if there is any requirement, you can add some additional terms also, and like some of the words like what, where, who, that. So there are some words where we can actually understand this like a query, and especially the very important goal is to retrieve the most important information from your documents, and also that content will be help us to, especially to summarize your text or to answer any question. For example, if a topic was given, for that topic we can raise a question. We should be also be able to identify the answer for a given question as well. So likewise, all this information retrieval systems will help us to identify all these things. And also we can use, by using your probabilistic retrieval models, so it will actually improve the estimation of how good the probability of a term existence can be taken by your set of documents as well. Okay, so these all things will be happen with the help of your background knowledge, and also how good a relevance of a term has been appeared. So how these both are actually helping for our query expansion. Okay, so your background knowledge, whatever background knowledge we have, especially with the topic. So likewise, we can take, for example, if we use thesaurus of a given document, how thesaurus is helping us to understand synonyms of your entire query. Because if you have a query or if you have a question to us, that question, every token, whatever we got, all those tokens will be understood by their synonyms of data. Okay, so likewise, it is a very special case. For suppose if you take CLIR and or MLIR, these are the two techniques especially we can use. So this will translate your query, so that after the translation, if you want to add any of the terms to that query, we can also take the help of your background knowledge to understand them. Next is relevance feedback. So this is a very important uh, metric. This is also having very good application, especially to understand how good every document is helping us to identify to make it as a question or it's a query. So this original thing will be matching with your document, and all these documents will helping us to identify which are relevant documents to retrieve a result, particular result. So because we might have a very huge corpus of data, that corpus of data might contain many number of documents, and not all documents might help you to provide you the result. The very good result will be identified from some particular documents. So those documents will be identified from very good relevance things. So that relevance thing, especially taken care with your monolingual information retrieval systems, especially by identifying the scores, whatever we have seen, your term frequency scores. Okay, and there is also one thing which is called a pseudo relevance feedback. So pseudo relevance feedback, which will be taking the top k documents of the first retrieval step, which are assumed, which you have assumed like they are relevant, and it also take this pseudo relevance feedback score, and it will also take this help in order to generate the queries and generate the very good possible relevance document terms, so that the information retrieval can be used in a very quick manner. Okay, so by taking them, we can identify the term frequencies in a very quick manner, and also this will be like your indexing. So first of all, it will be like index, like whenever a query happens, those number of top documents will be first indexed, and those documents will be considered especially first, and later if in no particular data was retrieved from the top k documents, then it will go to the next document. It is like ranking. It will rank all the documents. How good a document is helping us, likewise the query can be generated. So generally this PRF will be called it as blind relevance feedbacks. Next, coming to your priori. So how these priori models will be appearing. So priories are likewise whatever we have seen, the top k documents. So likewise some of the documents will be assumed to be uniform, because every document might give you some uniform results. So every time whatever query we will get, only those top k documents, whatever we have seen in your pseudo relevance feedback, all those documents will be prioritized, and this priori model will identify them as they are performing in a uniform fashion. So these probability values, whatever we are retrieving from your documents, so those will help us. So might every time those assumptions, whatever view we consider from those document, might be similar for every query, and sometimes might not be similar as well. So it depends on how good the document are, how good quality they are, how good popular they are. Popular means how many times a particular document has been ranked every time whenever we want to generate any query. So there are some factors, especially which will influence the priori probability of a document, and also it might also provide uh, the high quality documents generally, and which are more relevant as well. So this influence, especially on such priori probability documents, will help us to identify, and will also help us to summarize this text most efficiently. So all these probabilistic language models, but all the probability priori models, whatever we are going to consider, which those will also make your efficient retrieval models as well. So without, for suppose if you are not having any good background knowledge, the priori models which will identify the uniform results of some particular documents will also provide a very good result in order to retrieve your information. Okay, so thank you.